This video is based on an article originally printed in Advance magazine and was written by Curtis A. Parvin, Ph.D., John Yundt-Pacheco, and Max Williams. A link to the original article is provided in the video description. Consider this scenario. You just had a QC rule violation for your sodium assay. After some additional investigation, you confirm that the sodium assay is indeed out of control and has been running high. Prior control results were high, but not unacceptably so. Now they are. What should you do? CLIA Section 493.1282b2 says all patient test results obtained in the unacceptable test run, and since the last acceptable test run must be evaluated to determine if patient test results have been adversely affected. The laboratory must take the corrective action necessary to ensure the reporting of accurate and reliable patient test results. Recovering from an out-of-control condition always has an element of difficulty, but it can be much easier with some preparation. One of the most important things you can do in preparation for analytical problems is to establish how much error in a patient's result can be tolerated before it's considered unacceptable for its intended use, and how many unacceptable patient results are likely to be produced as a result of the test system experiencing an out-of-control condition of a given size. One way to characterize the amount of patient result error that can be tolerated is the use of total allowable error TEA limits. If the error in a patient's result is less than the specified TEA, the result is considered acceptable for its intended use. Conversely, if the error in a patient's result is greater than TEA, the result is considered unreliable. If TEA limits have not been specified, it's hard to determine whether a given set of patient results are reliable. Test method performance, imprecision and bias, coupled with TEA limits, dictate the capability of a test system to tolerate error. The ratio of TEA to analytical imprecision, or when bias is considered TEA minus bias over imprecision, has been referred to as the sigma metric of the process. Test methods with low sigma metrics have lower error tolerance than high sigma test methods. Unreliable patient results produced during the existence of an out-of-control condition can be divided into two intervals: those generated before the last acceptable QC event, pre-good QC, and those generated between the last acceptable QC event and the QC rejection, post-good QC. Based on the TEA specification, test method performance, power of the QC rules employed, and the frequency of QC testing, the expected number of unreliable patient results pre- and post-good QC can be estimated for any possible size out-of-control condition. This illustration shows an analytical process where the number of unreliable results generated prior to the last good QC is about twice as large as the number of unreliable results generated after the last good QC. The vertical strokes represent patient specimens being examined. The green diamonds represent acceptable QC events, and the red diamond is a QC rejection. The asterisk represents an unreliable patient result. The vertical shift in the analytical process represents a persistent error condition that's resolved after it was detected by the QC rejection. It takes 3 QC events to finally reject and identify the error. While unreliable patient results were produced during the out-of-control condition prior to the last accepted QC event, a significant amount of time has likely passed, making them difficult to identify and correct. For all practical purposes, patient results produced prior to the last accepted QC event are final. However, the unreliable patient results produced between the last accepted QC event and the QC rejection are recent and should be regarded as correctable. Patient results produced after the last accepted QC need to be evaluated, possibly re-examined, and corrected if necessary. These are also the results addressed in CLIA 493.1282b2. Limiting the number of correctable unreliable patient results is critical to recovery. It's possible to predict the expected number of unreliable results produced for any magnitude of out-of-control condition. Small out-of-control conditions are difficult to detect. They may persist for a long time before they're finally identified and corrected. As a consequence, most of the unreliable patient results produced during the existence of a small out-of-control condition will have been reported prior to the last acceptable QC. Fortunately, because the out-of-control condition is small, the number of unreliable patient results produced is relatively small. Large out-of-control conditions can produce a large number of unreliable patient results. However, large out-of-control conditions are relatively easy to detect. Therefore, for large out-of-control conditions, virtually all of the unreliable patient results are correctable because they were produced between the last acceptable QC and the QC rejection. Here we see an example of an analytical process during a malfunction that creates a large out-of-control condition. When a very large out-of-control condition occurs, half the number of patient results tested between QC events can be expected to be unreliable. It's prudent to make sure that your laboratory would not be overwhelmed by such an occurrence. In summation, after an out-of-control condition has been detected, there are several things that should be done. We suggest that you pause the video. This will allow you to review the following recommendations. For all of your laboratory QC needs, go to www.qcnet.com.